This question asks us to look at the probability of people testing positive and testing negative when they actually have something or don't have it. So that's what they mean by false positives and false negatives. A false positive, right, of 19 is where they tested positive even though they didn't have the thing, right, whatever they're testing for, high blood pressure, HIV, cancer, whatever. When you're faced with these types of questions, I always feel the best thing to do is to draw yourself the table so you can kind of visualize where all the numbers are, especially if they start asking given probability questions, conditional probability, because then it makes it a lot easier to figure out conditional probability if you have it set up in this table. But for these two questions, we don't have to worry about that. They're pretty straightforward. So we're going to pick four subjects, right? We're going to do part A first. We're going to pick four subjects, and the big thing here is that we're selecting with replacement. And then they want to know what's the probability that all four of them have true negative test results. Okay, so we're picking four people, and we're putting them back each time. And they all have to have true negative test results. Well, a true negative test result is a negative test result when they actually were negative. So those are our true negatives. So the probability that the first person that we pick satisfies this is good over total, 37 over 137. And since we're putting them back each time, the next person is also 37 over 137, and the third person is the same, and the fourth person is the same. And we always multiply our dashes together, right? Because whenever we're doing multi-stage probability things, it's always multiplying them all together. And if you multiply that all together, you get a very small probability. I'll round to there. And then you can round to whatever number you're supposed to round to depending on the answer they're looking for. And then part B, right, so this was part A. Part B we'll do in blue. Again, we're looking for four people, but this time without replacement. And we're still looking for all of them had true negatives, right? So we're still looking for true negatives, but now because we're not replacing them, these become dependent events. So the probabilities shift because our first person we have 37 out of 137, good over total. But now that person's been chosen and set aside, and so now when we go back and choose another person and that person also has to have a true negative, we now only have 36 good choices because there's only 36 people remaining who had a true negative, right? Out of 136 total. And then 35 out of 135, and finally 34 out of 134. And now we have to multiply those together, which gives us an even smaller number. Let's do 276, and again, round to whatever decimal place you're rounding to. Let's look at one extra bonus example. I know it's not part of this question, but a typical question would be we'll call this part C, what's the probability of choosing someone who tested positive, right? Given, that's what the vertical line means, given they were negative. Right? So it's the idea of what's the probability of getting a false positive, right? Given that we know that you're negative. See, it's a different question than just saying what's the probability, and we'll do both of those. We'll do this one first. What's the probability of just getting a false positive? Right? What's the probability of getting a false positive just means if you're one of these 137 people, what's the chance that you get a false positive? And we're not taking anything into account. And you go up here and go, okay, well, where are the false positives? Well, these are our false positives, right? These are the people who got a positive test result even though they were negative, right? They didn't have the thing that it's testing for. And so that is just simply 19 out of 137. This question is quite different because it's saying what's the probability that you get a positive test result given that we know that you don't have it. And so now that we're given that you are negative, our total is no longer 137, right? We still have, we're looking for people who get a positive test result, but instead of looking at all 137 people, we're only looking at those people who have a negative test result. So the given condition just resets the total. Instead of looking at everybody, we're only looking at those people who are negative. And so now our total is just, what is that, 56, right? Instead of 137. And so now out of those 56 people, how many of them tested positive? 19. Different question, hugely different answer. So that's the biggest stumbling block with probability, is really paying attention to the details in the questions.